Deductive reasoning, that's what we're going to talk about today. Deductive reasoning is a process of reasoning using given and previously known facts to reach a logical conclusion. So what you have in front of you right now is our truth table for conditional statements. So this is the one that we talked about a couple of days ago, where if the hypothesis P is true and the conclusion Q is true, then the conditional must be true. We also said that if the hypothesis is false, it doesn't matter whether the conclusion is true or false, our conditional is still going to be true. The only time our conditional is false is if we have a true hypothesis but a false conclusion. That's the only time you'll get false. Let's take a look at a couple examples here. What we're being asked to determine is whether, given a conditional and its conclusion, can we figure out whether the truth value of the hypothesis. So here, given that a conditional and its conclusion are true, can you use deductive reasoning to determine whether the hypothesis is true? So we're given that a conditional is true, which would be these three that I put dots by. So given that a conditional is true, those are the only options. And its conclusion are true. So of these three options, the only ones where the conclusion is true are these two. It says, can you use deductive reasoning to determine whether the hypothesis is true? So if my conditional is true, my conclusion is true, my hypothesis could be true. But if my conditional is true and my conclusion is true, my hypothesis could be false. So here, no, we cannot determine whether the hypothesis is true because it could be true or it could be false. Either way, the conclusion and the conditional are both true. So here, no, we cannot determine whether the hypothesis is true. Okay, next. Given that a conditional and its hypothesis are true, can you determine whether the conclusion is true? So, conditional is true, where I'm putting the pink marks. So, given that a conditional is true, let's look at when the hypothesis is true. These are the only two times the hypothesis is true. Can you determine whether the conclusion is true? So, if I'm looking at my two true hypothesis rules, and then I'm looking at my conditional, the only one of those two where the conditional and the hypothesis are both true, the conclusion has to be true. So here, given that a conditional and its hypothesis, so conditional and hypothesis are both true, can you determine whether the conclusion is true? And the answer is yes. The only time that both of these are true, your conclusion is also true. So yes, your conclusion must be true. Okay, so at the bottom of the page here, you have a concept picture, and this is for the law of detachment. So we're going to talk about two things in this lesson. The first one with deductive reasoning is the law of detachment, and then the next one we'll talk about is the law of syllogism. So the law of detachment is a law of logic that states that if a conditional statement and its hypothesis are both true, then the conclusion is true. And that's what we just found here in part B. So if P then Q, if the statement if P then Q is true and P is true, Q has to be true. And that goes back up here. If your statement, your conditional, if P then Q is true and your hypothesis is true, your conclusion has to be true. It has no other option. So let's go ahead and take a look at the next side of our notes. So using the law of detachment, we're going to look at a couple statements and determine if we can figure anything out from those. So here on example 2, it says, if two angles are congruent, then the measures of the two angles are equal to each other. So we're going to assume that that's true. So we're going to assume that if two angles are congruent, then the measures of the angles are equal to each other. Next, they tell us that angle 1 is congruent to angle 2. Since we said that our conditional was true, Angle 1 being congruent to angle 2, that's your hypothesis. Two angles are congruent. Since we're saying that they're congruent, what can we conclude about the measures of those angles? We can conclude that those angles are equal to each other. So we can write the angle measures are equal, or you can write the measure of angle 1 equals the measure of angle 2. So they are equal to each other. So you can either write that the angle measures are equal, or you can write it the way you would see it when we start doing angles next chapter. The measure of angle 1 equals the measure of angle 2. Next, it says, if you finish the race in under 30 minutes, then you win a prize. So this is your conditional. If you finish the race in under 30 minutes, then you win a prize. We're going to assume that that's true. Next, it says you finish the race in 26 minutes. If you finish the race in 26 minutes, you finished it in under 30. That means this is a true statement. So if your conditional is true and this, your hypothesis, is also true, so here your hypothesis is true, what can we conclude? We can conclude that you win a prize. Next, we're going to look at the law of syllogism. So the law of syllogism is a law of logic that states that given two true conditionals with the conclusion of the first being the hypothesis of the second, there exists a third true conditional having the hypothesis of the first and the conclusion of the second. So if we look at this, so we've got if P then Q and if Q then R are both true, then we can state if P then R is also true. Notice that the conclusion of one statement, so the conclusion of one statement was the hypothesis of the next. And if both of these are true, then we can kind of cut out that middleman and say if P, then R is also true. So here's what that looks like. Down here on example 3, it says if an integer is divisible by 6, it is divisible by 2. If an integer is divisible by 2, it's an even number. So the first thing we had, and I'm going to underline these in pieces, is if an integer is divisible by 6, then it is divisible by 2. Notice that this part, the conclusion, is the same as the hypothesis on the next part. If an integer is divisible by 2, then it is an even number. So because the conclusion of one statement is the same as the hypothesis of the next conditional, and we are assuming that both of these conditionals are true because that's what the directions tell us to do, we can write a new conditional that says if an integer is divisible by 6, then it is an even number. So let's look at another one. It says, if it is a holiday, then you do not have to go to school. If it is Labor Day, then it is a holiday. So the part that is repeated is this holiday piece. So what if we reordered our statements? What if we said that if it is Labor Day, then it is a holiday, and make that our first statement. And then we can say if it is a holiday, then you do not have to go to school. If I work backwards, and we start in reverse order, we start with the second sentence, notice that the words holiday here are repeated. So the conclusion of my first statement is the same as the hypothesis of my first. So let me back up. The conclusion of my first statement is the same as the hypothesis of my second. So we would rewrite this as if it is Labor Day, then you do not have to go to school. So if it is Labor Day, then you do not have to go to school. The last thing we're going to look at is what happens when you combine the two. So we're going to look at both the law of detachment and the law of syllogism. So last side of your notes here, we're going to draw some conclusions. So it says here on example 4a, what conclusions can you draw from the following true statements? So we have to believe that everything that's in here is true. It says, if you are climbing a mountain at an altitude of 28,500 feet or higher, then you are on the tallest mountain above sea level on Earth. If you are on the tallest mountain above sea level on Earth, then you are on Mount Everest. So the first thing I want to do is use the law of syllogism and write a new statement. So it says, if you are climbing a mountain at an altitude of 28,500 feet or higher, then you're on the tallest mountain above sea level on Earth. If you're on the tallest mountain above sea level on Earth, so that's the part that's repeated, then you are on Mount Everest. So we're going to look at this first part. If you are climbing a mountain at an altitude of 28,500 feet or higher, okay, and then we come down to the next part, then you are on Mount Everest. So that is using your law of syllogism. So that's our statement, what I underlined. Next, it says you are climbing a mountain at an altitude above 29,000 feet. Because this hypothesis right here, you're climbing a mountain at an altitude above 29,000 feet. Because 29,000 feet is 28,500 feet or higher, it makes this hypothesis true. If it makes the hypothesis true, and we've already assumed that the conditional is true, then that means the conclusion has to be true. So that means you are on Mount Everest. So once again, the law of syllogism let us create this statement. You're climbing a mountain at an altitude of 28,500 feet or higher, then you're on Mount Everest. Then if you're given some information that makes that hypothesis true, so 29,000 feet is more than 28,500 feet, then that means we are on Mount Everest. So we're currently on or climbing Mount Everest. Next is example B, and it says, Martin walks his dog before dinner every day. Martin is now eating his dinner. It says, using the law of detachment, what conclusions can you draw from these true statements? So these are not necessarily written as if-then statements. You could rewrite them as if-then statements if that would help you. Otherwise, if we know that Martin walks his dog before dinner every day, and he's currently eating dinner, then that means he's already walked his dog, because he's going to walk his dog before dinner and he's eating dinner. That means he's already walked his dog. Okay, so just a quick recap. When you have deductive reasoning, we use deductive reasoning with the law of detachment and also with the law of syllogism. Law of detachment states that if your conditional is true and your hypothesis is true, then your conclusion has to be true. The law of syllogism states that if you have two conditionals that are both true, and the conclusion of the first statement is the same as the hypothesis of the second statement, you can cut that repeated piece out and you have a third conditional that is also true if the hypothesis of the first statement and then conclusion of the second statement, and that makes your third conditional. With that, you have the rest of class time to work on your 1.6 additional practice that you should have gotten with your notes.